So for the network shown in the figure, determine RE, ZI, Z0, AV. Z0 and AV, that is output impedance and voltage gain, you have with an assumption of R0 is equal to infinity or infinite ohm, and repeat repeat parts B and D including R0 is equal to 50 kilo ohm. Okay, so now let us see the figure. So in the figure, you know that this is your resistance R1, R2, RC, RE, CE, C2 and C1. So what type of biasing it is? It is a voltage divider biasing. And the model, what we have to do, small signal analysis, the modeling is used is the RE model, right? So first, what is your step 1? As we have done in the previous problem, step 1, we are going to replace this circuit with its equivalent RE model. So if we want to replace it with its equivalent RE model, you have to short all the capacitors, right? Capacitors, and eliminate the DC effect, that is VCC, eliminate it, right? So you will not get this, and this will be shorted, this will be shorted, CE will also be shorted. So due to the low impedance, your resistance also will be, RE also will be shorted. So your RE will not be included in the case of your RE model. Okay, so let me draw the RE model now. So now first you are going to replace the transistor by its equivalent RE model. So what will be your input side? Input, the resistive effect will be equal to beta RE. Output, parallel combination of a current source with that of your output resistance, which is taken as R0. So what will be this point? Emitter, collector, and this is your base. So this will be your transistor. Now the transistor is replaced by its RE model. Now you can see into the circuit. In the network, whatever you have R1, R2 and RC, right? So R1, if you take the effect of VCC, you will be getting R1, the other point to be grounded. So you can, one point from the base you have R1 and R2, both is grounded. So I can reconfigure it into two resistance, right? R1 parallel to R2. Similarly, in the output side you have the resistance RC, right? And this is going to be your output, input, right? Looking into the circuit, it is ZI. From the output, looking to the circuit, it is your output impedance Z0. So now you are going to calculate all the parameters. So for example, in order to calculate the first value RE, what you have to do, you have to do the DC analysis. So you have to go back to your DC analysis of your voltage divider biasing. So you know that what is the formula for RE? RE is equal to 26 millivolt divided by IE, right? So what is this 26 millivolt? VT. Now if you want to calculate this IE, you have to go you have to do the DC analysis. So we can do actually the approximate analysis. So in the case of approximate analysis, you have to test the condition. So what is your condition? DC testing to be done, that is beta RE should be greater than or equal to 10 times of R2. So what is your beta given? Beta given is equal to 90. So 90 into what is your RE? RE is equal to 1.5 kilo ohm, which should be greater than or equal to 10 into what is your R2? R2 is equal to 8.2 kilo ohm. So what will you get? 135 kilo ohm should be greater than or equal to 82 kilo ohm. So yes, it is satisfying the equation, satisfies. So you can proceed with the approximate analysis. So in the approximate analysis, you have you know already the formulas. So what will be your VB? What will be your VB? VB is equal to, apply the voltage division rule. So R2 into VCC divided by R1 plus R2. So R2 into VCC divided by R1 plus R2. What is your R2 now? 8.2 kilo ohm. 8.2 kilo ohm into your VCC is equal to 22 volt divided by, what is your R1? 56 kilo ohm plus, what is your R2? 8.2 kilo ohm. Okay, so 8.2 into 22, you will be getting 180.4 into 10 raised to 3 divided by 56k plus 8.2k, approximately you will be getting 64.2 into 10 raised to 3. So you will be getting VB will be approximately equal to 2.81 volt. Okay, now you have got the value for VB. So you have now calculated what is your VB, but you know, also you know that this voltage is equal to VB and this voltage is equal to VE. So what is your VB? VB is equal to VBE plus VE. From this, can you calculate VE? VE will be equal to VB minus VBE. So now let us calculate the value for VB, right? So now VB, not sorry, VE, right? So VB is equal to, what is the formula? VBE plus VE. So from this, can you calculate what is your VE? VE will be equal to VB minus VBE. So what is your VB, which is calculated 2.81 volt minus 0.7 volt. So you can you will get that VE is equal to 2.11 volt. Now you have got VE. Now can you calculate your IE? So you know that IE is equal to VE divided by RE. So 2.11 volt divided by, what is your RE? 1.5 kilo ohm. Right, so IE will be approximately equal to 1.41 milliampere, right? IE also you have calculated. Now you can come to the point. So RE is equal to 26 millivolt divided by IE, which is equal to 26 millivolt divided by 1.41 milliampere. So milli will get cancelled. RE will be equal to approximately equal to 18.44 ohm. Okay, so you have got now the first part. So A part is done. Now you have to start off with your B part. Okay, so now moving on to your B part, what is the value you have to find out? Input impedance. So you know that input impedance is equal to R dash parallel to beta into RE. So what is your R dash? R dash is equal to R1 parallel to R2, right? So I hope so you know this. Zi is equal to R dash parallel to beta into RE. Say, so for example, if you take the input side, what you will be getting? R1, R2, R1, R2, and you will be having beta into RE, right? Across the input side. So what will be your total input impedance? Input impedance is equal to R1 parallel to R2 parallel to beta into RE. That is what R1 parallel to R2 is taken as R dash. That's it. Okay. So first you can calculate what is your R dash. R dash is equal to, what is your R1? R1 is equal to 56 kilo ohm parallel to, what is your R2? 8.2 kilo ohm. So what you will be getting? 56 kilo ohm into 8.2 kilo ohm divided by 56 kilo ohm plus 8.2 kilo ohm. So R dash will be approximately equal to, so you will be getting 459.2 into 10 raised to 6 divided by 64.2 into 10 raised to 3, right? So this will get cancelled. So you will get R dash is approximately will be equal to 7.15 kilo ohm. Okay. Now you have got R dash. Now can you substitute Zi is equal to R dash parallel to beta into RE. So it will be equal to 7.15 kilo ohm parallel to, what is your beta? Beta is equal to 90. 90 into, what is your RE? 18.44 ohm. So Zi will be equal to 7.15 kilo ohm parallel to 1.66 kilo ohm, right? So Zi will be equal to, apply the formula, 7.51 kilo ohm into 1.66 kilo ohm divided by 7.15 kilo ohm plus 1.66 kilo ohm. Okay, so you will be getting Zi will be equal to, approximately equal to, or you will be getting 11.869 into 10 raised to 6 divided by 8.81 into 10 raised to 3. Okay, so cancel it. So Zi will be approximately equal to 1.35 kilo ohm. So this is your input impedance. Okay, now C part, you have to find out your output impedance. So you know that in output impedance, keeping input as constant, what is the only parameter you have to you will be getting in the output side? You will be having beta into IB and your output resistance. But in this third part, you have R0 is infinite. So R0, the original formula is RC parallel to R0. So if this is very greater, if it is infinite, and since it's a parallel combination, you will be neglecting the higher value, and Z0 will be equal to RC. So RC directly you can write the formula, it is 6.8 kilo. So you have got the value for Z0. Now D part. D part you have to find out AV. AV also, what is assumption here taken? R0 is infinite, right? So you the formula here is minus RC divided by RE. Original formula is RC parallel to R0. So since this is very high and it's a parallel combination, we are going to neglect it. So you will be getting minus RC divided by RE. So minus RC is equal to 6.8 kilo ohm divided by RE is equal to 18.44 ohm. So what is your value? AV is equal to minus 368.76. Okay, now you have to repeat, that is the E part, you have to repeat C and D. So first let us repeat C with taking into consideration the output resistance is equal to 50 kilo ohm now. So what will be the value now? Z0 will be equal to RC parallel to R0. So what will be your RC? 6.8 kilo ohm parallel to, what is your R0? 50 kilo ohm. So you will be getting, what will be the formula? 6.8K into 50K divided by 6.8K plus 50K. Okay, so approximately you will be getting it as 340 into 10 raised to 6 divided by 56.8 into 10 raised to 3. So both will get cancelled. So you will be approximately, you will be getting the value as 5.98 kilo ohm. Okay, Z0, that is with the effect of R0. That is, let me write it here, it is equal to Z0. Now the last value to be calculated is, second, the last value will be your D part repeated again. So what will be your D part? Sorry, AV. So AV repeated along with R0. So you will be getting RC parallel to R0 divided by RE, right? So what will be your RC value? Minus 6.8 kilo ohm parallel to, what is your R0 value? R0 value is equal to 50 kilo ohm, right? Divided by, what is your RE? RE is equal to 18.44 ohm. So here already you have calculated the value, right? RC parallel to R0. That is nothing but your output impedance. So already you have calculated the answer. So which will be equal to minus 5.98 kilo ohm divided by 18.44 ohm. So you will be getting AV will be approximately equal to minus 324 24.3. Okay, so these are the values which you have got. So if I make it into a table, say for example your value for Z0 and AV without R0 and including R0 is equal to 50 kilo ohm. So what will be the value without R0? What will be the value? Z0 will be equal to 6.8 kilo ohm. With R0 the value will be equal to 5.98 kilo ohm. Similarly AV will be equal to minus 368.76, that is without R0, and with R0 the value will be equal to minus 324.3. Okay,